It's Thursday, the 27th of June, 2024, and welcome to the Water Action Platform. I'm Lauren Former, and this month we're getting molecular about the chemicals that are on all of our minds and all around us, PFAS. As a PFAS expert myself, I'm excited to take you along in conversations with global colleagues who are collaborating and innovating to end forever chemicals in the water cycle. Up today, we've got a closer look at the groundbreaking new PFAS regulations in the United States, what one of the largest groundwater utilities is doing about PFAS, and an inside look at the latest research in novel treatment technologies. But stick around to our "and finally," where you'll experience probably one of the most creative ways to make sense of decades of climate change data. All of this, of course, is only possible because of our incredible sponsors listed here. Thank you. Now, let's dive in. PFAS, per and polyfluoroalkyl substances, all 15,000 plus of them, a chain gang of carbon stubbornly holding on so very tight to their fluorines. Here are just two of them: TFA, an ultra short chain, PFOA, a long chain. They're short chains. There's so many different kinds. They were so useful that we used them in all kinds of products, but now we're realizing the scale of their negative impacts and trying to pry them out of water. So first up, my colleague, Dr. Patrick Dubé, he will tell us about how years of research now led the United States to introduce groundbreaking federal regulations for drinking water. So Patrick, tell us what's been happening with PFAS in the United States.
In October 2021, the US EPA announced the agency's PFAS strategic roadmap, which outlined the actions and commitments that the agency would make in regard to PFAS through 2024. And their approach focused on three main directives: research, restriction, and remediation. And over the past 3 years, the EPA has undertaken a science-backed approach to address PFAS in the US. This recently culminated with the first ever national legally enforceable drinking water standard to protect communities from exposure to harmful PFAS. And with around 66,000 public drinking water systems in the US, the EPA estimates that around 6 to 10% of these utilities may have to take action to reduce PFAS to meet these new standards. Now, the 6 PFAS chosen to be regulated were selected because of the clear science behind their link to significant health impacts. And these health risks include kidney and liver cancer, developmental effects, thyroid and liver issues, and more. And although the EPA did not quantify all of the health benefits that addressing these PFAS will bring, they estimate the effect will be greater than around $1.5 billion per year.
Which PFAS exactly are being regulated then?
EPA is establishing legally enforceable levels for 6 PFAS that are known to occur individually and/or as mixtures in drinking water. 5 are enforced individually, and those are PFOA and PFOS, which have a minimum contaminant level of 4 parts per trillion. PFNA, PFHXS, and GenX have a minimum contaminant level of 10 part per trillion. And then PFNA, PFHXS, GenX, and PFBS are regulated as a mixture around a hazard index MCL. And this hazard index with a value lower than 1 essentially indicates that no known or anticipated adverse impacts on the health of persons occur, and it also allows for an adequate margin of safety with respect to health risk.
What's the time frame for compliance on these new rules? And what do you think we'll be seeing in the next 5 years?
So the EPA stated that this rule is achievable and implementable, and drinking water utilities should be able to reach these new requirements using technologies that exist that are already in use today. Those technologies include things like granular activated carbon, reverse osmosis, and ion exchange systems. So typically the Safe Drinking Water Act, which is under which this rule was developed, generally provides a 3-year timeframe for compliance with these new rules. But because there's significant capital improvements to systems that need to occur to comply, the EPA exercised its authority and extended the typical 3-year timeline to 5. So what's going to happen over the next 5 years? Well, over the next 3, by 2027, public water systems must complete initial monitoring and then follow that with ongoing compliance monitoring. Water systems also need to provide the public with information on levels of PFAS in their drinking water beginning in 2027. And then public water systems have 5 years, so until 2029, to implement solutions that reduce these PFAS if the monitoring shows that the drinking water levels exceed these MCLs. And then also beginning in 2029, public water systems that have PFAS in their drinking water, which violate one of these MCLs, must take action to reduce the levels of the PFAS and provide notice to the public of the violation.
Oof. How much do you think all this will cost?
So the EPA estimates that the costs for public water systems to implement and reach the levels in the regulation are approximately $1.5 billion per year. And they have also provided some funding to help offset these costs. So the bipartisan infrastructure law is providing $9 billion specifically to invest in communities where with drinking water impacted by PFAS and other emerging contaminants. And then states and communities can also leverage around $12 billion in the state revolving funds that are dedicated to making drinking water safer. And then the EPA is also taking additional actions under its PFAS strategic roadmap to hold polluters accountable.
Thanks again, Patrick. It's great to hear that there will be dedicated funding available to help water utilities meet these new regulations. So let's hear it straight from a water utility themselves. My colleague, Dr. Rashima Williams, spoke with John Kmiec from Tucson, Arizona, and here they are talking about where a community that so values water is dealing with their biggest PFAS challenges.
With that, welcome to the Water Action Platform, John. It's great to have you here.
Thank you very much. Good to be here.
So to start, a little bit of a get-to-know-you softball question, John. What first brought you into the water sector, and what makes you excited to get up in the morning?
All right. Well, great question. A little bit of background about me. I did not grow up in Arizona. I actually grew up outside of Detroit. So I spent a lot of my time in the Great Lakes, and most of that time in my childhood was always around water, whether it was a river, a stream, a lake, fishing or swimming. So just loved fresh water, loved the Great Lakes region, but then found myself in Arizona. What really got me into the water sector and the public water space was when I was immediately out of university. I was an environmental consultant, and I helped actually clean up a lot of very contaminated groundwater and soil sites, particularly in the Midwest, before I moved out west. And then I decided I was tired of cleaning up other people's messes. I wanted to be more fixed with a community that focused on the value of water, and that I made my way to Tucson, Arizona, which was completely different than growing up in the Great Lakes. But the people out here really pay attention to water issues, and I was able to find a great home here, and love being now the director of Tucson Water.
Fantastic. It's almost the opposite of my story because I grew up in the Middle East and then came to the University of Illinois for college. So we basically went in the opposite direction, but ended up in very similar places. That's really interesting. So as you mentioned earlier, today's Water Action Platform episode is dedicated to all things PFAS. And so, John, where has Tucson Water seen its biggest challenges with PFAS and why?
Yeah, the PFAS is a huge issue here in Tucson. We are one of the largest utilities in the United States that's still a groundwater utility. So we have several hundred wells around the Tucson Basin and the basin west of Tucson called Avra Valley that produce our drinking water supply. Unfortunately, being a groundwater system in a major metropolitan area, that comes with challenges of contamination. Tucson had to deal with a huge contamination issue of TCE back in the 60s, 70s, and 80s, and we're still dealing with that. And then 1,4-dioxane about 20 years ago. And then a few years after the discovery of 1,4-dioxane, we actually discovered perfluorinated compounds in some of our wells in the late 2000s. So we've known about PFAS and PFAS issues since at least 2009. in the Tucson area. And then it was more of a curiosity back then as an emerging contaminant. Didn't really know what it meant, where it was coming from, but we sure know what it means now. We've now honed in over the last decade at two major airports, Davis-Monthan Air Force Base, as well as Tucson International Airport, which has the Morris Air National Guard base associated with it, and the groundwater underneath both those sites, as well as moving into the Tucson Water service area, is highly impacted with perfluorinated compounds.
Mm-hmm. That's fascinating. So, what is Tucson Water doing to treat some of the PFAS contamination coming from those two airports then?
So right now, we do have where we had our TCE and 1,4-dioxane plant near the Tucson International Airport.
Mm-hmm.
We've added other GAC filters for dealing with PFAS. That's now in that same well field. And so we've been treating it there. Mostly, though, in the Tucson area, is we've been avoiding it. So as we discover wells that have PFAS impacts, we've been shutting those wells down. So we've shut down more than 28 wells in the Tucson area where over the course of a number of years we detected PFAS. But now we're looking at getting treatment to bring some of that water supply back, because it's really putting a strain on our resiliency for our water system. So we do have a couple projects that we're moving forward with. One in particular, it's going to bring 3 wells back on the northwest side of Tucson with advanced oxidation for emerging contaminants like 1,4-dioxane, but it will also be a PFAS removal facility as well. And that'll bring about 3 million gallons a day back into our portfolio. And then we have, we'll be looking at a series of all those other wells that have been turned off, and over time, how we can bring those wells back.
That's fascinating. So it's almost a resiliency and water resources issue as well as a water quality issue for you all.
Absolutely.
How do you see the EPA's new MCL guidelines for PFAS affecting your utility moving forward?
Actually, we welcome that the EPA has finally gotten to a point where they issued the MCLs and actually issuing now PFOA and PFOS to be considered hazardous substances under CERCLA. One of the biggest challenges for us is having the responsible parties start to reimburse or pay for the cleanup of the Tucson aquifer. So now that there's set regulations in place and moving forward, that'll allow the city of Tucson and Tucson Water to more aggressively look to those responsible parties for contributing to the cleanup of PFAS in the aquifers of Tucson, and provide that funding for the utility to get some of our lost assets back into play. That's been one of the things that has been holding us back from doing a lot of treatment, because the citizens of Tucson should not have to pay for an issue that they have not created. So we wholeheartedly at the city welcome the advancements in the regulatory platform with EPA, because that gives everybody more clarity on how to move forward and how to get PFAS out of our aquifer system.
Now to look even closer at other novel options we have to remediate PFAS, we went to Dr. Moha Ateia Ibrahim from the US Environmental Protection Agency. I got to ask Moha about their PFAS research efforts at the EPA Office of Research and Development and the Center for Environmental Solutions and Emergency Response, which is quite a name. As a disclaimer, however, what Moha says in this interview is his personal opinion and not the EPA. With that out of the way, let's ask Moha.
Hi, Moha, and welcome, and thank you again so much for joining us on the Water Action Platform. Please tell us more about your research in PFAS treatment at the US EPA.
Yes, so we have a pretty broad umbrella of when it comes to the PFAS research. I can summarize it into 4 main directions. 1 is detection. 2nd is separation. 3rd is destruction. And 4th is regeneration of spent media, which can be under also like waste management part. So detection can be branched into 2. 1 is how to detect PFAS, so like method development to like get drinking water, wastewater, solid media, analytical methods, and also detection where. So exploring new places to search for PFAS, so like biosolids, soil matrices, and landfill leachate, etc. So this is under the detection part. Separation can be also branched into two: conventional methods and novel technologies. Conventional covers like granular activated carbon, the GAC, ion exchange resin, or membrane separation like nanofiltration or reverse osmosis. But also not limited to that, we have an eye out for anything that is emerging. So that can be novel adsorbent media that is more selective for PFAS, so that can selectively and easily, quickly separate the PFAS from water or wastewater. Destruction, it is a must, because separating the pollution is not enough. We need to make sure that we are degrading it to elements that they are not toxic. So we are exploring wide array beside the conventional like thermal technologies, non-thermal like plasma, electrochemical, photoelectrochemical technologies, mechanochemical destruction, so that we can cover later any different scenarios that requires PFAS management. The regeneration comes, if you follow the news recently, like PFOA, PFOS, two of the PFAS are designated as hazardous material under the Superfund law. So that now the question how to deal with the spent media, like can be granular activated carbon or ion exchange resin. So now we are exploring, there's thermal regeneration facilities that it is existing in most or many of the water treatment utilities, but also we are exploring novel technologies to desorb or separate PFAS from these surfaces.
Yeah, super interesting. And could you also tell us some more about, in all of this work, what the role of collaboration is in these innovations?
Our work is very, very collaborative. So we collaborate with academic labs, with government labs, different government branches like DoD and the Navy. We also collaborate with industry. So if there is an emerging technology in the market, we always have an eye out to see what is has good potential, if it is fitting to our evaluation framework or like treatment portfolio. We work with any of these entities and compare them in a fair manner. So like we see which technology fits which treatment train for a specific scenario, that kind of sequence.
Yeah, great to hear. And just picking up on that last remark as well, how might you wisely go about that, choosing which PFAS technology for which scenario, and how have you seen that discussion develop in the last years?
Yeah, our understanding about the overall issue with the problem with the PFAS is now much more mature. So no one is currently looking for a silver bullet or a one-size-fits-all solution. Mm-hmm. We know that the issue needs to be dealt with like with a treatment train where you separate PFAS first and then subsequently destroy it in that concentrated form that can be liquid or solid. So we take it step by step. We think about what is the initial concentration, what are the background constituents, set so that our selection for the separation technology is also data-driven. And then once it is concentrated, we can think about, okay, we have a liquid or solid waste that it is contaminated with PFAS, how to deal with it. So we think about the scalability of the technology. We can think about the energy needs. Do we have access to like a very easy example that we don't think about it frequently, like remote islands that they don't have like a reliable grid. So
that was on our last WAP.
Yeah, so can we satisfy these needs with a technology or two? What are the options for inland versus offshore scenarios? So yeah, it's a multi-layer, but again, to sum that up, it's just like our understanding is getting better, but our understanding of a specific need is more critical, because this is how we can filter different treatment technologies and design a treatment train that can fit it.
It's great to see the world community collaborating on this and all the research is going into it. What gives you the most hope when you think about your work and the research going into PFAS remediation?
So many different perspectives are coming now, like chemical engineers or organic chemists and environmental engineers are now collaborating. So they talk to each other, like modelers, computational chemists. You see different disciplines are working on the same area that I don't see it in other or trying to solve other problems. So this gives me a great hope, because I'm sure some of these discussions will just bring some ideas that we don't know about it now, but it will stem out of these kind of collaborations and discussions. So I'm always optimistic, but that gives me actually the most hope.
And we need lots of hope in the world, and that's definitely my big banner, interdisciplinary work. So thank you for joining us in this endeavor, Moha. It's been really a pleasure getting to hear your perspective and getting to learn so much from you. Thank you again.
Thank you so much.
And finally, we're going to jazz it up a little with a musical number for you. Sonification is a process where one takes digital data, which we have a lot of, and converts it into sound to try and better understand and comprehend that data and hopefully make good use of it. Hiroshi Nagai from Risho University in Japan recently published a sonification exercise. The talented scientist and equally talented musician took climate science datasets and interpreted them into a composition for a string quartet. Datasets on downward solar radiation, atmospheric temperature, ground temperature, cloud thickness, rainfall, all of these were used to turn science into rock and roll. How do you think it went? Let's take a listen. Do I hear thunderous applause? I'd say that was a marriage of science and art. to see if it helps us better understand our world. However, please pass on any compliments or complaints regarding your musical taste to our Piers Clark. With that, we come to the end of this month's broadcast. Once again, I'd like to thank all of these fantastic sponsors and all of today's great contributors. The July Water Action Platform will be a special edition hosted by Dr. Joe Burgess. We hope you can join us. Until then, keep asking questions, keep sharing, and keep safe.